Okay, so we're doing binomial probability here. Okay, so binomial probability means bi means two. So there's two answers, either yes or no. Okay. Now the big thing here is when you're looking to figure out if you need to do binomial probability, it's independent and you're looking at an exact number. Those are two things you want to see. It's independent and exact number. Okay. So the binomial formula is right here. So let's just rewrite it all. This is the third time I've made this video, unfortunately. So probability of x equals k, that just means what you're looking for, is nck times p to the power of k times 1 minus p to the power of n minus k. So as we go through here, I'll do this. Bring this down some. So p is probability, n is the number of trials you're going to have. Okay, k are the number of successes that you're looking for, multiplied by the probability of success to the power of k times 1 minus p, which is the probability of failure, to the power of n minus k. So essentially, this is the number of successes. This is the number of failures. Okay. And the other equation for today is going to be e to the x equals np, as in your expected number. So what's your average? What should have you have got? Okay. So let's do a question here real quick. I have remnants of my last answer. So the probability of rolling a 4 on a dice 3 times in the next 10 rolls. So we're doing 10 rolls, so that's going to be my number of trials. K is the number of successes we're looking for. So we're looking for 3 successes. P is our probability. So if we're rolling a dice, and we're trying to get just a 4, that's 1 out of 6. And then our probability of failure is going to be 5 out of 6. You can also get that by going 1 minus 1 out of 6. So let's plug everything into our equation. So the probability of x being 4, x being 3, equals 10c3. So it's 10 trials, I want 3 to be right, times 1 over 6 to the power of 3, that's how many successes we want, times 5 over 6 to the power of 7. Okay? Now we're going to plug that into our calculator. 10c3 times 1 over 6 to the power of 3 times 5 over 6 to the power of 7 should give us about a 16% chance, 0.16. So there's a 16% chance that the next 10 rolls, 3 of them will be a 4. Okay? Then we could do, what's the expected number of 4s? So what's the expected number of 4s would be n times p. So that'd be 10 times 1 over 6, which would be 10 times 1 over 6, 1 2/3, so 1.7. On average, we're going to get 1.7 4s when we roll the dice 3 times. So Larry Bird shot 89% during his career from the free throw line. Okay, I forgot to put that in, on free throws. During the NBA Finals, Game 3 against the Lakers, he shot 15 free throws. What was the probability that he would make exactly 12 shots? Okay, so n is our number of trials, that's going to be 15. And I always encourage you to stop the video, see if you can figure it out yourself, and then make sure it checks out with mine. K is the number of successes, so I want 12 successes. P is the probability of success, so 0.89. And 1 minus P is the probability of failure, so it's going to be 0.11. So we're going to go write it down. NCK times P to the power K times 1 minus P to the power of N minus K. So we're looking at 15 choose 12, then 0.89 to the power of 12 times 0.11 to the power of, how many misses do we want? 3. So 15 choose 12 times 0.89 to the power of 12 times 0.11 to the power of 3. So there was a 15% chance of him hitting 12 exactly of 15 free throws. My expected number, what's my expected number of free throws? Would be N times P, so 0.89 times, oh, I got those mixed up, times 15. 15 times 0.89. On average, he's actually going to hit 13.4 free throws. So he's actually a little below average. So Jimmy forgot to study for his multiple choice quiz. The multiple choice quiz has 4 possible answers for each question and 1 being correct. What's the probability he gets 4 out of 8 right if he's guessing? All right, so N is 8. How many do we want right? 4. The probability of him being correct is 1 out of 4, or 0.25. And the probability he is mistaken is 3 out of 4, or 0.75. So it's going to be 8C4 times 0.5 to the power of, not 0.5, 0.25 to the power of 4 times 0.75 to the power of 4. Now this is not his probability of passing, because he could also get 5 right, 6 right, 7 right, or 8 right. We're just looking for 1 here. So 8C4 times 0.25 to the power of 4 times 0.75 to the power of 4. So the probability he will pass with exactly 50% is about a 9% chance if he's just guessing. So approximately 3% of the eggs in the store are correct. If you buy 2 dozen, what's the probability that none of the eggs are correct? 2 dozen is 24. In this case, we're looking for 0 eggs correct. Our probability of that happening is 0.03 to find a cracked egg, and 1 minus P is going to be 0.97 for it not to be cracked. Now, as an aside, we could run the numbers the exact same way, but think of K as in number that are not cracked, that are whole. 0.97, 0.03, oops. Okay? And you actually get the same answer because we're just figuring out the opposite way. So it's going to be 24. What did I just write? 24C0 times 0.03 to the 24 times 0.97 to the 0. 24C0 times 0.03 to the power of 24. Now we don't need to go 0.97 to the power of 0. No, that's a 1. Don't like what I got here. Oh, shoot. I did that wrong. This is backwards. that should be 0, that should be 24. There we go. I had it right on the paper, but not what I wanted to do. So 24 C0 times 0.03 to the power of 0 times 0.97 to the power of 24. So 48% chance. Okay. Now that would be 0, and that's going to be 24 minus 0 to get me that number. Now what's the probability exactly 2 eggs are cracked? Would be n would be 24. My k this time would be 2. My p is still 0.03, and my 1 minus p, 0.97. So 24 choose 2 times 0.03 to the power of 2 times 0.97 to the power of 22. Oh, crap. So it's a 13% chance. If we wanted to figure out what the expected number of eggs, or the expected value of it that breaks, it would be n times p, so 24 times 0.03. So on average, 24 times 0.03. On average, you're going to have 0.72 cracked eggs per 2 dozen. All right. We'll do one last one. So this is actually true. During Mr. O's championship games in basketball in high school, I shot 22 for 23. During the season, I shot 76%. What's the probability I'd shoot this well? So n is 23. My k I'm looking for is 22. My probability is 76, so 0.76. So 1 minus p, my probability of failure was 0.24. Very highly unlikely I would get all these in. But stranger things have happened. 22 and 0.24 to the power of 1. So it's pretty much a 1% chance of me doing that. What should have been the number I got in? Well, that's n times p. So 23 times 0.76. If I was shooting average, I would have made 17.5. And we would have been on from there. Okay, so have a good day and off to the next one.